In this video, we're going to be talking about bivariate regressions and how to do a regression in SPSS, and then what the different parts and pieces of the regression mean. So, we first started by opening up the General Social Survey 2008 data. This is the subset that we've been using this semester. And now we're going to pick our variables. I'm going to go with the same variables that I used before with the correlation. I'm going to go with education and how many children do you have. And so I'm going to say that education is my independent variable and that number of children that you have is my dependent variable. So I'm going to go to Analyze, and I'm going to go to Regression. Now you'll notice that there are a lot of options for regression. There are lots of different ways that you can do regression. We are going to stick with linear regression, so that would be the second option here in the window. So again, Analyze, Regression, and then Linear. So here is what you've got. You've got a place to put your dependent variable and then a place for your independent variable. And this will allow you to do more than one variable if you have a complex question or you have other control variables. So I'm going to right click and I'm going to display variable names, and number of children is my dependent variable and education is my independent variable. Now, I'm not going to mess with anything else. I'm going to leave it just like that, and I'm just going to get a simple linear regression. So I'm going to click OK, and my output looks like this. So my output is going to have 4 parts to it. Let's make that bigger. Alright, so there are 4 parts. This first box that you get with the regression simply tells you what variables are in your model and how those were put in. And so this one's doesn't really tell you anything you don't already know. It tells you what your dependent variable is down here, and it tells you what your independent variable is up here. Okay, then we have what's called our model summary. And our model summary gives us our R. This is actually Pearson's R, except for it doesn't have the negative in front of it, but you'll notice it's the same number as what we got when we did the correlation matrix. This also gives you something called an R square, and we've talked about that. This is the coefficient of determination. And then you also have an adjusted R square. Now this gets adjusted depending on the number of independent variables you have. So since we only have one independent variable, you don't have a big difference between R square and the adjusted R square. But this is the number that you would use as the coefficient of determination. Then if you scroll down, you've got an Anova for the relationship, and this basically tells you if your model overall, this line of best fit, overall, is this a good model? And so if this is significant, which in our case it is, because this SIG is below 0.05, then what that tells us is that this is a good model. And the independent variables that we've included in this model are a good predictor of that dependent variable. Okay, so then we go down to our coefficients table. And this is where we actually get our line of best fit. So the constant is our y-intercept. And so this 3.919, that's our y-intercept. And so if we were to do an equation based on this, this is our b value and this is our a value. So the negative 0.145, that's our b. So if our equation is bx plus a, then it's negative 0.145x plus 3.919 equals y. So that would be the equation for our line of best fit. So this is indicating that there's a negative relationship between education and number of children that you have. For every 1 year of education that you accomplish, you are likely to have 0.145 fewer children. That's how you would interpret that. And then if you look over, you'll notice that they do a t-test to test for statistical significance, and you'll see that it is in fact statistically significant. So overall, what you're looking for in the regression output is you're looking for the line of best fit, and that is given to you here. So again, this is your A value, this is your B value in your equation, Bx plus A. And then you've got some other things that are useful, but that you can get elsewhere as well. So the most important thing to remember here is your equation for the line of best fit. All right, and there will be more about the interpretation in the PowerPoint for this section.